I think I could identify three main areas where I felt I made an important contribution. One was in the development of the ground motion model. That's probably the central, most important. In addition to that, we spent some time studying liquefaction hazard. And the third contribution would be in the organization of the MMAX workshops to discuss the maximum credible or the maximum possible earthquake that could occur in the Groningen field. And those three together, I think, have been important contributions to the hazard and risk modeling exercise. So we began almost immediately after the housing earthquake, looking at the small database we had of ground motions then, and adapting European models to fit the Groningen data in the small magnitude range. But we rapidly moved to much more advanced modeling, and at the same time, the networks were expanded, and the KNMI operated recording networks. So as the years went by, we had an increasingly large database of ground motion recordings to work with, and we recruited more and more people into our team. People specialized in the inversion of recordings, people who are specialists in site response analysis. So finally we had a team of 6 or 7 experts working together with backup from other people at KNMI and at Deltares, and developed what we believe is a very sophisticated model, which was also subjected to continuous review by a panel of 8 of the leading international experts in ground motion. And we were also able to publish many of our results along the way, and all of the publications had to go through peer review as well by other specialists in this field, so that we had a wonderful database, a uniquely informative database, supplemented by measurements at the recording stations, so we knew a great deal about the nature of these recordings, analyzed by a large team, a model developed by a team of experts working together, and as I said, subjected to various levels of peer review, all of which contributed to what I believe is an excellent model. I think in many ways, in terms of ground motion modeling for induced earthquakes, we set a new standard, which was a privilege we were able to achieve because of the amount of data available to us and the time afforded to us to undertake this work. So we have a model which is very sophisticated in terms of reflecting the characteristics of the earthquake source in the shallow gas reservoir where the earthquakes are originating, the way they propagate through the very specific layers of the Zechstein salt and the other formations above the reservoir, and in particular then how we capture the influence of the soft soils that are present throughout the field, but how they vary spatially, those soils, and the particular ways they amplify or dampen the ground motion at different frequencies. So we produced 2 models, finally. The first model is only for peak ground velocity, which is a parameter used for assessing damage, particularly in the assessment of damage claims. And that's a model which is only applied in the same range of earthquake magnitudes that have actually occurred in the field. So that's derived by empirical regression on the data, and that's a very robust model which very effectively reproduces the average behavior of the ground motion that's been observed. The second model predicts a parameter called the spectral acceleration, and this is related a parameter that measures how buildings actually respond, and that's a model used in the risk analysis. And that was a more challenging problem because for that one we had to extrapolate the model to possible, even if they are rather unlikely, possible future earthquake scenarios of much larger magnitude than the ones that have actually occurred. That second model is still calibrated to what we know about the field, but also has to capture the inevitable degree of uncertainty as a result of such large extrapolation beyond the data. So that one particularly benefited from the interaction of a team and the process of continual peer review by an international panel. So the work has been published in some very extensive reports, all of which are publicly available on the NARM website, and a long series of papers published in international journals. So the work is entirely out there for anyone who wishes to inspect it. In fact, the last paper we published is the full data set. So the database is now freely available with full explanation for anyone who would like to reproduce or improve on our work. Obviously, the ground motion model for spectral acceleration has been implemented in the hazard and risk analysis, And the PGV model has been used extensively by the state and other organizations in the assessment of the impact of the earthquakes in terms of damage with a view to assessment of damage claims. And that freedom to publish the work has actually been characteristic of all of the work we've undertaken for NAM. So we published all of the ground motion models. We also published all of the work conducted to demonstrate that liquefaction hazard is effectively negligible in Groningen, and also all the work conducted for the MMAX workshop was also made available through publication. Indeed, participants in all of this work have been encouraged by NAM to publish their work openly.
Despite whatever contracts you got from Furcroft, there's absolutely no requirement for confidentiality. This is entirely open, everything we're going to be talking about. And in fact, we actively encourage participants to publish the work that they've undertaken for the workshop. If we have, the Groningen Hazard and Risk Project has an amazing publication record already, and if you can add to it by publishing your work, that would be encouraged. If you can include an acknowledgement to NAM, that would be appreciated by NAM. But please do go ahead and publish any work that you've undertaken. There is absolutely no confidentiality clause whatsoever. And if you are under contract, time you spend on such publications can also be charged to your contract.
Well, obviously I became very involved with the work. I have felt very invested in trying to make the best products we could on all of these topics that I've worked on. It's been very interesting and educational for me to work with so many people and to face robust challenge from some quarters which we've had to respond to. So it's been a great learning experience which I've taken into other projects related to induced earthquakes. I think for most of the people who got involved in this, they'll look back on it as a big step in our research careers, what we learned and what we published on this project. Perhaps on the more disappointing side is the frustration, the fact that we did what we believe is world-class work. It's a groundbreaking work in terms of modeling not only the ground motions but risk, hazard and risk due to induced earthquakes, and that work seems to have had relatively little impact on policy. Personally, I find that frustrating, because obviously the whole purpose of, I'm an engineer rather than a scientist, so as an engineer, I like to see the science applied to solving societal problems, and when you have such an investment to conduct this kind of world-class research and then see that decisions are made almost independently of the science is disappointing, to put it mildly. Just as it's frustrating for us that all this work was not really used in a lot of the decision-making in terms of policy, it's also frustrating that the work has been terminated, since I believe had we been able to continue, we could have further refined these models. I believe the models are perfectly defensible and fit for purpose. Indeed, they're world-class, but of course we could have always improved somewhat. We were able to publish a final version 7 ground motion model, which has also been published. And the final activity in which I have participated was the conducting of the MMAX workshop in June of 2022.
This is the final event in NAM's scientific study program. There's now a policy called NAM at a distance. NAM is basically out of scientific study. So all the work on the ground motion prediction models and site response on the fragility and consequence model has all been terminated. And the work on the seismic source modeling has officially also been discontinued, apart from this workshop focused on MMAX, which should have happened quite a long time ago.